goals, but it's still in the developmental stage. So how well it meets them and how user-friendly, that's another question. But it's moving forward rapidly in an exciting manner. So I think we should probably get into it, because this is the part I think that you guys, most of you all were hearing, much more interested in seeing. We'll break for questions partway through this section and at the end of this section, and then break for questions after the discussion. So as far as the decision support system, this current application of it is built in the raster environment, and I think everybody here is pretty familiar with what the raster environment is, so I won't go into it in much detail. I guess since I am recording this, I might as well do the quick skinny. The landscape's divided into a raster of cells. Each cell has a value corresponding to that particular layer of information. And then the cells that overlay directly with each other, you can actually do mathematical operations on. And so here are two hypothetical rasters. You overlay them on top of each other. You can do some algebra, for instance. You could do a sum. So in these two, this is a very simple schematic. Lots of times rasters have millions of cells that overlap exactly with the other layers of millions of cells. So the top left cell of that layer has a value of 1. The lower left cell of that layer has a value of 0.5. You can do a simple addition. And you get your output layer is the addition of all the cells of all the layers that were involved. The weighted sum is where you actually just assign a weight to each particular layer. The weight is based on a variety of things, such as the importance and or you can involve the uncertainty of the layer as well. And you end up multiplying the weight times the actual value of the cell and adding the result of that product to the weight and product of another layer, and you get your weighted sum. So that's one of the fundamental concepts of this whole framework. And so here's an example. If you're looking at trying to get the biodiversity value of a spatial unit, a simplified example is saying, okay, well, what's the composition of that unit? You know, what's actually there, and also what's its spatial context? How does it relate to everything that's around it? And so what's there could be based on the habitat representation value, a species representation, and a structural representation. Structural representation is really growing big in dealing with this issue of climate change. So looking at the soils and the topography and the microclimate that's there, not necessarily the actual vegetation or species, but preserving the stage, so to speak. And you can make a whole variety of spatial context criteria as well. And in this case, the weighted sums were all equal. So here is a weighted sum between composition and spatial context, goes up to biodiversity value. Here we have these three things. They have an equal or relatively equal weight, and so on and so forth. Then you can combine your biodiversity value with a variety of other different values that are important to the decision at hand. So you can look at social value, economic value, ecosystem services. Again, these are just the tip of the iceberg as far as example criteria that can go into this framework. And then you also want to consider this issue of threat and the idea of what's going to happen if you don't do anything. And so this is programmed into the framework as well. And you can turn on or turn off this aspect with a little bit of tinkering. And so you actually end up getting your net benefit of your proposed action at place Y under scenario Z. Scenario Z, for the first time you do this, scenario Z can just be your prediction of the future. But you can also, once you get fancy, you can also do a couple different predictions of the future and see how that would affect your decision. So what we were just looking at was the net benefit of your proposed action. Now, what you also want to do, in the way I've been conceptualizing it, is to balance that with the feasibility of your proposed action. So it's one thing if your action has a lot of net benefit. If it's going to be really, really difficult to implement that action, you might want to reconsider. And so the difficultness of the action could be based on the actual financial investment of doing the action, the ongoing management costs of committing to that action, the political ecology of the whole issue, and that's, where the whole stakeholder process comes in, and the politics of the landscape, and all of that can be programmed into it in a spatially explicit manner. And so you can identify different parts of your region that are going to be much more feasible than other parts. They can even be the actual site, or congressional districts, or depending on what type of criteria you have and what kind of data you have. So the framework will balance those two and then give you some relative conservation priority for performing Action X, that place-wide given scenarios. Now, this is also a multi-objective system in the fact that you can look at, we just looked at action, what was it? Action X, also known as Action 1 in this slide. You can also look at Action 2 or Action 3 or Action 4. You can basically run the whole framework for these different actions. And each action might have different parameters for different issues and different data. And so you'll get slightly different answers. And so what you can do is you can identify, through this way, you can actually identify what are some of the recommended actions for each site. Not only which sites are best for which action, but what are the best actions for any particular site. You can incorporate that into your site selection model or simply your site assessment model. And I want to skip this slide, but this talks about some of the important things to consider about multi-criteria decision analysis, and one of the reasons why I'm such a big proponent of it. And this is an example of how it can really help bring a variety of stakeholders to consensus. These are data from the South African case study. And the long story short is the slide on the right shows the amount of disagreement between two different stakeholder groups. One was a state agency, one was a land trust. And then after doing this exercise, here's a lot more higher degree of agreement in their rank of the importance of the different sites. And so it's 10:35. I'd like to break for a minute for questions. This form bill looks kind of like a question mark, so it's my little cube to break the questions before we get into the site selection algorithm. So any questions so far?
John, I just have a quick comment. Could you go back to slide 24?
Yeah.
So the way that we have typically thought about this is in a cost effectiveness framework where you have the the benefit divided by the cost of action.
Mm-hmm.
But it looks like you're taking the benefit and then kind of
right.
doing something completely different.
Actually, I haven't updated this slide. I'm really glad you caught that. When we get to a later slide, I think I clarify that it is division right here. It's actually a weighted division, which is kind of, it took me a while to figure out how to do that, but it's experimental. But yeah, that's a really, really good point. This is benefit divided by cost, not a weighted sum. So thanks for that.
Okay, great.
Yeah, great. Thank you.
Who is it that's setting the weights in these?
Okay, and then that's the people setting the weights. That is based on the stakeholder framework that you have involved.
Okay, so that's kind of just decided by the people who are engaging in this process.
Exactly.
Could be different across different implementations.
Exactly. A good rule of thumb is that the lower down in the process, in the hierarchy, as far as visually speaking, the more, down in here at these levels, you really want to just have your hardcore scientists setting these ones, and maybe a few science stakeholder liaisons. But then when it gets higher up in the area, up in here, you really want to have, in general, you want more of your stakeholder process helping with setting some of those weights. Basically the decision makers should be helping setting some of those weights.
Has that been contentious ever in terms of people wanting the ability to set more weights than they're being allowed to, or anything?
Yeah, there's. It has been contentious, not in my experience, but just in the literature I've seen that, and there's actually some pretty slick ways of dealing with that, which I have a few citations in the in the white paper I have about this, I have a few citations on that. Helen Regan is a person that I respect a lot that's been looking into that.